Hello. Let's start discussing assignment number 10. So in this question, we are given this equation. Okay. And we are supposed to find F3. Okay. Let's see how to do it. Okay. So uh, we have this theorem, right? Fundamental theorem of calculus. And what does this says? If there is a function capital F of x, a to x, f t dt, and let's say f x is continuous from a to, let's say, b, and this x, obviously x is from a to b. Okay, now these are all assumption. Then what does it says? If such things happen, then f x is differentiable at x is equal to f x is differentiable at any x. Okay, and it is given by f dash of x is equal to f x. In fact, let's denote it by different variable. Okay, so this one is the conclusion, and this one is the how do you say it, assumptions. Okay, so let's see. So notice before using fundamental theorem of calculus, just I want to point out one thing. In this question, there is just this minor typo that you assume that f is actually continuous. Okay, so it should have been written in the question so that you can use the fundamental theorem of calculus. Then only you can use the fundamental theorem of calculus. Okay, so if f is continuous from, let's say, 2 to something, let's say 2 to at least greater than 3, something from, let's say, more than 3, let's say some quantity. I won't write it, let's say uh, d. Okay, where d is greater than 3. Okay, so something like this, then you can use fundamental theorem of calculus. And once you use fundamental of theorem calculus, it says that this if you differentiate it, let's say fx you denote by 2 to x, okay, if you differentiate f dash x will be fx. Okay, uh, in fact let's take this x or c is equal to 3, then this will give me f dash 3 is equal to f3. Okay, so okay, so that's what I'm going to use. So uh, I'm going to differentiate. Okay, if I'm going to differentiate, we already know what this is. This f3. F3 is no, we don't know. Okay, but this one we don't know. But you can differentiate this one, right? If you differentiate this one, you will get you get 2x sine pi x plus x square cos pi x. Okay, and this one will be pi. Okay, so I am using here this. We have this rule for differentiating, right? This product rule: df dx g plus f dg dx. This fact I am using. Okay, uh, so okay, I'm using those rules. Okay, so if I put 3, then it will be 2 into 3 sine 3 pi plus 9 cos 3 pi pi. Okay, sine 3 pi will be 0. This one, let's just erase this thing. But what about this one? This one will be 9 cos 3 pi will be mm, minus 1, right? Uh, yes, it will be minus 1 and then it will be pi. So this will be minus 9 pi. Okay, so this minus 9 pi f dash 3 equal to f3 is equal to minus 9 pi. F3. Mhm. So f3 is equal to minus 9 pi. So this one solves question number 1. Hi. So before moving on to question number 2, I want to discuss some extra problems. 1 star, 2 star. You can see it on the board because I feel like this is I mean will clarify your understanding more. Okay, and this part needs some attention. Okay. Okay. So okay. So yeah. Okay. So in this for question number 1 star, we are given this. Okay, and what we want to find fx. Okay. So what do we do? Again, since f is given to be continuous, we can use fundamental theorem of calculus. So I will differentiate both side of it. Okay. So d dx 1x ft dt and this side if I differentiate, you will get 2x minus 2. Okay, now you see, if you say, let's say fx is your 1 to x ft dt, okay, then f dash x is given by fx, right? And this whole part, this denote f dash x, right? Okay, and what is fx? Okay, so uh, if I use this is from fundamental theorem of calculus, so I can use fx is equal to 2x minus 2. Okay, this will do question number 1 star. Okay, now let's move to 2 star. So in 2 star we have to find f4. Okay, again f is continuous, and we are given this thing. Again I will use fundamental theorem of calculus. Okay, so what will be f dash capital F dash x? This one will be a small f of x, and note that if you differentiate with this x cos pi x, you will get the x cos pi x. If you differentiate, you will get minus sine pi by x into pi. Again, I'm using this chain rule, and also I'm using this product rule for differentiating. Okay, so keep in mind that okay, so if you differentiate x, this will be 1, and cos pi x will remain as it is. Okay, so you will get f small x, this will be x, let me collect terms, this will be like this, plus cos pi x f uh, uh what do okay, fx, right? 3, what should I do here? Okay, we want for f4. Okay, so f4 will be, put 4, you will get a minus 4 pi sine 4 pi plus cos 4 pi. Okay, and this one will be 0 sine 4 pi, and this cos 4 pi will be what? 1, right? So f4 will be 1. uh, this solve question number 2 star. Okay, thank you. Hello. Okay, let's begin discussing question number 2. Okay, so okay, minus pi by 2 to pi by 2 sine x plus mod sine x. Okay, so we have to integrate this. Okay, so let's first, this mod is going to be troublesome, so first we have to deal with it. Okay, so before that, before dealing mod, let's just look at the graph of sin x. Okay, if you see the graph of sin x, this one is something like this, and okay, pay attention to this part. Okay, okay, and This is what 0. This is pi by 2. This is pi. This is minus pi by 2 minus pi. Okay. And one thing. Okay. Yeah. So this is the graph of sine x. This is the one. Okay. How about what will be the graph of mod sin x? Okay. So what does mod does? It will make the negative thing positive. Okay. In fact, I will write the definition just to recall that. This it will be x if x is greater than 0. So it will left it unchanged if it is 0 or greater than 0. But if it is negative, something is negative, then it will just multiply with minus 1. Okay. And then give the value output. Okay. So let's see. Where is it negative? Here it is negative, right? Here, this part. Okay. So the graph will be something like this, right? So this one will be minus sin x. Minus is multiplied because here it was negative, right? So mod will in turn actually make it greater than 0. Okay, by multiplying it with minus 1. Okay, so how will our this part look like? Okay, so okay, now I am going to, with green color, I'm going to restrict it between minus pi by 2, this and this, minus pi by 2 to pi by 2. Okay. Okay, then see this. This is the required area, right? Okay. Can you note? Uh, okay. So, okay, just this was just to clarify things. Let's go ahead and evaluate this integral. Minus pi by 2, pi by 2 sin x plus mod sin x dx. Okay, this will be minus pi by 2. I can write it like this. Okay, and then from 0 to pi by 2 sin x plus mod sin x dx. Okay. Uh, we observed this, right? From minus pi by 2 to 0, the definition for mod x will change. So let's just how do I say it? Incorporate that change. So here it will be minus sin x. Okay, note this minus. That I explained why it will be multiplied with minus. Okay, so sin x minus sin x, this will get deleted. It will be 0. So you will from 0 to pi by 2 sin x plus this mod sin x will be this will just open up as sin x, because from 0 to pi by 2, as we have noted, this won't change, right? Already positive. Okay, so this will be 2 sin x 0 to pi by 2. Okay, and one more thing, 0 to I'm going to use fundamental theorem of calculus again, not the one that we used in question number 1. There is this theorem, right? When if you want to f of x dx a to b, if you want this, then this is equal to gb minus ga, where g is one antiderivative. Okay, g is any antiderivative of f, and antiderivative is defined by this thing, right? G dot what is the definition that this, okay, this is the definition of antiderivative. Okay, so if this thing if g is any antiderivative of f, then this thing is true. Okay, okay, so this is a fundamental theorem of calculus. Okay, okay. This fundamental theorem of calculus I'm going to use, where f is our fx is equal to sin x, and with gx is equal to what you can take I think minus cos x, because if you check g dash x will be minus, and differentiate cos x, you will get minus sin x. This will get sin x. Okay, uh, so we have verified that g dash x is equal to fx, that is g is antiderivative of f, and with a is equal to 0 and b is equal to pi by 2, if you use this thing, you will get integration of sin x 0 to pi by 2. You will get what, g pi by 2 minus g 0, and g pi by 2, that is sine pi by 2 minus sine 0. Okay, sine pi by 2 is equal to 1 minus 0, this will be 1. Okay, but note that we want to find 2 into this thing, right? So your final answer will be 2. Okay, this does question number 2. Okay, so now let's move on to question number 3. Uh, okay, by the way, there is another thing that I want to say. Uh, Please, I have attached some feedback link in the description. Please consider filling it. I really need the feedback for two reasons mainly. One, I want to see if it's really useful, the video I'm making. And two, I want to see for myself that is it actually am how I'm doing, like am I presenting it clearly. Okay, and there is this other another part that if most of you I mean give me like if it is really useful, if I get good feedback, then I will consider also doing videos for uploading videos for your next course, linear algebra, or this calculus too. Okay, so please fill out this form. It will be helpful for me and helpful for you, I guess. And yeah, actually, I put a lot of effort. It's not like I just go randomly open my tab and write. I think before I speak, uh, I try like before saying, I think about how can I explain my best, and it also take a lot of time, just uh, I record it using this screen recorder, then I have to transfer it to my laptop, and then from laptop this I have to download it, and from there I have to convert it into a fixed frame rate video, so that it is suitable for editing, and then I watch it again, see if there is any correction, and I apply this noise reduction thing, and then actually I render this. After rendering, I have to upload, the drill, so I won't actually bore you, so please consider writing the feedback. It is attached in the description. Okay, let's start the question number 3. So in this question, find the area of the region bounded by the graph y is equal to 3 minus x and x square minus. Okay, so let's how do I'm going to rush through it because uh, I have continuous PhD interviews to attend, and yeah, so I don't have much time, so I will just rush through this 3, 4, and 5. Okay. Mm, okay, so 3 minus x. If this graph should be something like this. Okay, y is equal to 3 minus x, and y is equal to x square minus 9. This will be first. Let me. Y is equal to x square minus 9 will be something like this. Where will it? Okay. Okay, and this side it will meet somewhere around this. Okay, to find this point, I'll just equate. Here we have y, both of the y values are same, right? So 3 minus this y1, let's say y2. So 3 minus x and this x square minus 9, we have to find. Okay, y and x value agree. So if you equate this and this, you'll get x square plus x. This will be what? 12. X square plus x minus 12 is equal to 0. This will be x square plus 4x minus 3x minus 12 is equal to 0, x plus 4 minus 3 x plus 4 is equal to 0, so x minus 3 x plus 4. Okay, x is equal to 3 is equal to 3 and minus 4. Okay, so 3 and this 3 already we have done, minus 4 0. Okay, so this will be minus 4 and y will be 7. Okay, okay, so the area that we are interested in is this one. Okay. Mm, okay, so how will we find this? Area will be given by which is the see which one is above? This 3 minus x is above. 3 minus x is okay. Ignore the background comments. Okay, so okay, so what I'm going to do is I'm this above one. Let's denote this by fx, that is this one. You denoted by fx, and this one going to be gx. Okay, so you want to find the area, you will do fx minus gx. Okay, okay, and the limit will be from minus 4 to 3. Okay, this minus 4 to 3. Okay, so minus 4 to 3, fx will be 3 minus x, and gx will be x square minus 9 dx. Minus 4 to 3. 3 minus x square plus 9 dx, and this will be minus 4 to 3. This will be 3 minus x minus x. Okay, so I think not adding anything new. So this you consider minus x square, and 9 and 3. This will be 12 dx. Okay, so now again I will use fundamental theorem of calculus, and this time uh, fundamental theorem of calculus, this one I'm recalling, this one, this fx dx from a to b, you'll get gb minus ga, where f x satisfies this thing for all x belongs to a b. Okay, so this one is the fundamental theorem of calculus. This one I'm going to use with a is equal to minus 4, b is equal to 3, and fx is equal to minus x square plus 12. Okay, and g will be consider g to be this one. But then you check g dash x will be fx. Okay, so I can now write g 3 minus g minus 4, and I think you can calculate the rest, I believe. Okay, So I'm going to skip question number 4. It's in similar spirit. Okay, and uh, okay. So this one is. I don't think 4 is much harder. Okay. It's in similar spirit. We will move directly to question number 5. Okay. So let me write the question number 5. Okay, this one, right? Okay. So let's begin. Okay, so I'm going to write t as x cube plus 1, and then dt will be dt dx will be no, yes, I'm doing it correctly. I'll get 3x square. Okay, so I can write it as dt dx. This one will be okay, so this will be root t. Yes, and then x square will be what? Okay, 1 by 3 dt dx will be x square. So 1 by 3 dt dx. Okay. So if you see this one will come out to be 1 by 3 root t dt. Okay. Then 1 by 3 t half plus 1 half plus 1. Okay, so you will get 1 by 3 t 3 by 2 3 by 2 t3 by 2 9 2 plus c 2 and now you can replace t by x cube plus 1 3 by 2 9 plus c. Okay, so this finishes question number 5.